The updated flow models finally explain why the Milky Way is moving.
For a few days, the system appears recoverable. Researchers redraw the superclusters using corrected velocity maps. Long gravitational currents begin connecting structures once thought separate. The simulations align. The trajectories hold.
Then the calculations finish.
The flow continues beyond the Great Attractor. One model pushes the gravitational center farther outward. Another shifts the direction sideways entirely. A third collapses once hidden mass corrections are applied. The measurements improve. The disagreement becomes structural. The Milky Way was already moving before humans realized anything was wrong. The sky looked stable. Observatory schedules continued normally. Teams in California and Australia repeated the same redshift measurements night after night, while galaxy maps filled with arrows all pointing the same way. But they did. Hundreds of galaxies were drifting together. Not randomly, not evenly. Toward the same region of space. An astronomer in Arizona reruns the calibration after midnight because the galaxies keep shifting in the same direction. Another observatory compares its own data hours later. The velocity changes are smaller than expected. The direction stays locked. Galaxies are supposed to spread outward in every direction. But entire clusters are sliding sideways together. At first, the problem looks local. Timing drift between observatories, bad reference points, maybe a telescope issue. Teams trade measurements back and forth while older sky maps stop lining up with the newer ones. The corrections stabilize nothing. The farther they look, the more galaxies join the same movement.
The data clearly indicates
Galaxy after galaxy joins the same flow.
However, if we examine the
and the source sits directly behind the Milky Way itself. The part of the sky humans cannot fully see. Which means the largest coordinated movement ever detected may already be happening behind the part of the sky we cannot fully see. The thing pulling the galaxies was buried behind the Milky Way. Every deep sky survey kept failing in the same place. A dark band stretched across the center of the Milky Way, where dust and stars became so dense that entire regions behind it disappeared from view. The galaxies kept drifting, but every survey hit the same wall of interference. Teams switch wavelengths. Radio scans begin mapping shapes that optical telescopes cannot see. Infrared observatories cut through parts of the dust field and reveal partial structures behind the galactic plane. Then the surveys stop agreeing with each other. One survey shows concentrated mass. Another shows empty gaps where that mass should be. An operator stands beside overlapping sky maps while software struggles to align conflicting scans from different observatories. The processing takes longer each night because the reference systems begin breaking under the amount of missing data. More observation should reduce uncertainty. Instead, every new wavelength creates a different version of the same hidden region. The same region of space now looks different depending on how humans scan it. And the obstruction is enormous. Millions of light years of deep space remain partially blocked behind the Milky Way, while galaxy clusters on both sides continue accelerating towards something nobody can fully map. Teams begin stitching incomplete surveys together just to keep the motion maps usable. But the stitched maps keep expanding. The hidden region behind the galaxy appears larger every time the darkness breaks apart. The Great Attractor was no longer the whole problem. The reconstruction finally starts producing consistent maps. Researchers combine infrared surveys with galaxy velocity maps and redraw the boundaries of local superclusters based on how galaxies actually move through space. The new flow maps look wrong immediately. Now the movement forms patterns. They stream together in long, connected currents across hundreds of millions of light years. Entire superclusters that once appeared separate now move as part of one larger structure. Laniakea. The corrected maps finally explain why the Milky Way is drifting. For a few days, the system appears recoverable. An analyst rotates the updated model while automated calculations rebuild galaxy trajectories cluster by cluster. Older cosmic maps remain open on nearby monitors beside the replacement model. Then the new calculations finish. The flow does not stop at the Great Attractor. It continues beyond it. If the corrected model is accurate, the flow should narrow toward one destination. But the farther the surveys extend outward, the less stable the destination becomes. The structure that was supposed to explain the drift now appears to be drifting too. Every correction pushes the boundary farther outward. Supercluster edges shift again. Directional flow lines stretch farther into regions still partially obscured behind interference and incomplete observation. Humanity may have identified only one layer of the motion, while something even larger continues pulling the entire structure farther off course. And now the maps no longer agree on where the galaxies are actually going. The data improved faster than agreement did. New simulations begin rendering across research centers at the same time. One model places the gravitational center beyond the Great Attractor. Another shifts the flow sideways across a larger structure. A third breaks the movement apart entirely once hidden mass corrections are applied. The maps stop matching again. Researchers begin arguing over interpretations built from the same measurements. Velocity surveys improve, telescope interference drops. The measurements become harder to dismiss. Yet every refinement pulls the models farther away from each other. An astrophysicist pauses during a conference presentation while two projection screens behind him display different flow directions for the same galaxy clusters. Nobody interrupts because both simulations still match parts of the observed motion. If the measurements improved, the disagreement should shrink. Instead, the disagreement becomes structural. Some groups argue the motion is real. Others believe the distortion may come from the way humans measure the motion itself. Older cosmology models remain active beside newer reconstructions because replacing them completely would break decades of comparative research data. So the field keeps operating with competing versions of the same universe. Galaxy clusters continue moving through partially modeled space, while competing simulations assign different destinations to the same flow structures. The corrections no longer restore trust. They expose how much of the system depended on assumptions nobody fully tested.
Stable.
And the motion never stops.
Parameters.
The drift remains measurable across observatories, even while the explanations fracture underneath it. Researchers can track the direction. They can measure the velocity. They can watch entire regions of space continue sliding together. But they still cannot fully explain what the galaxies are actually falling toward. The universe still behaves consistently. Humans just no longer fully understand why. The simulations continue running anyway. Modern flow models stretch across enormous sections of mapped space before fading into blind zones where the structure can only be inferred instead of directly seen. The Milky Way keeps rotating through the center of it all, while hidden regions behind the galactic plane remain dark inside every reconstruction. But the motion still predicts correctly. Galaxy clusters arrive where the equations predict. Velocity measurements continue matching observed drift patterns across enormous distances. The system still works. Navigation through the local universe remains reliable.
Humans still cannot fully see the structure underneath it.
An astronomer leans back from a workstation while a cosmic web simulation updates another layer of inferred mass beyond visible observation. The software now fills gaps automatically because too much of the structure remains unseen. Nobody fully trusts the invisible sections, but removing them breaks the model completely.
Prediction still works. Direct visibility does not. So the field adapts.
Researchers continue refining motion maps by measuring galaxy behavior instead of directly observing the structure controlling it. Billions of stars keep moving through gravitational architecture that remains partially hidden behind interference humans still cannot penetrate cleanly.
And the flow continues beyond every completed map.
The arrows continue beyond the edge of observable reconstruction into darkness the model still cannot resolve. The Milky Way keeps moving toward the same hidden direction, while the largest structures humans can measure continue disappearing into regions nobody has fully seen.
The galaxy is still falling toward something beyond the part of the universe humans can clearly see.